Okay, so what we're going to do today in terms of the research portion is correlation coefficients. And we talked about relations before. We talked about how relations can vary in systematic ways, where if one variable goes up, the other variable goes up. And we talked about positive and negative relations, but today we're going to talk about specifically the strength of relations. And we're going to highlight how these correlation coefficients, these numbers, can sometimes be used incorrectly to bias results or to present untruthful results. So before we get to that, just a reminder that we are talking with correlation. And correlation does not imply causation. It does not equal causation. But you will be surprised how quickly that flies out of your mind, especially if you see a correlation that makes sense to you, or that has a pretty, it seems obvious or intuitive causal link. So it's always good to remind yourself that correlation, many things are correlated that have in no chance, in no way could possibly be causal. So for example, there is, and this is from TylerVigan.com, they have a collection of spurious correlations. Apparently, the per capita cheese consumption correlates with the number of people who died by becoming tangled in their bed sheets. So if you take a look at the national statistics year to year of how many people died in bed sheet tangling, and you take a look at the national statistics year to year of how much cheese has been consumed, well, it is a very tight correlation. Now, I don't think anybody here would argue that somehow consuming cheese makes you vulnerable to bed sheet tangling, or that somehow getting tangled in bed sheets would cause the surviving family members to just consume large amounts of cheese, right? I don't think anybody would make that argument, and yet the correlation is strong. So again, a good reminder that correlation does not imply causation. Same thing with divorce rates in Maine are actually correlated with the per capita consumption of margarine. So both of those have decreased over the last decade. And the list goes on. Age of Miss America, so the age of the Miss America winner, correlates with murders by steam, hot vapors, and hot objects. So when Miss America is older, when she's older, we have more murders by steam, hot vapors, and hot objects. When Miss America is younger, we have fewer murders by steam, hot vapors, and hot objects. And I don't think anybody would believe that people are sitting at home and watching Miss America and going, how old was that Miss America winner, 27? Give me my hair curler and I'm gonna go out and, nobody thinks that, right? But look at this correlation. Look at that. When one goes up, the other one goes up. When one goes down, the other one goes down. And this is one of my favorites. I don't know if it's got to be updated for his recent output. But the number of people who drowned by falling into a pool and the films that Nicolas Cage appeared in are, again, highly correlated. And this one might have a more plausible connection. I don't know if people don't like Nicolas Cage films and just decide to end it. But anyways, it's correlated, but it doesn't imply causation. So always keep that in mind. But what we're going to be talking about today is when things are interpreted as just being correlated, they can still be interpreted incorrectly. But before we get to that, we need to identify or be clear on the concept of the correlation coefficient. So a correlation coefficient, it's a statistic. It's a number that tells how strong a relationship is between two variables. How strongly correlated are these two variables? So by example, all of these ones that I just showed you would have a very high correlation coefficient because they were all very correlated with each other. Now we do this because when you're describing a relationship between two variables, we as human beings will place it somewhere. It'll be placed somewhere on this continuum. So not even us as human beings, but it will be placed somewhere on this continuum. It's either going to go somewhere between having no relation with each other, changes in one variable are not associated with any change in the other variable, or it's going to have a perfect relation, where changes in one variable are exactly associated with changes in another variable, Chances are, though, it's going to be somewhere on this continuum, right? Weak relation, moderate relation, strong relation. And these have, again, describe how tightly the two variables vary together. So, for example, if this was the relation between increases in mood and increases in exercise, if there was no relation, this is what it would look like. So if this is, each dot is an individual person who exercises a certain amount and has a certain mood, right? That's what each of these dots represents, as an individual person. If this was the relationship between exercise and mood, then there would be no relation, because people who exercise little have low and high moods. People who exercise a lot have low and high moods. There's no relation between exercise and mood. That would be a no relationship relation. This would be a weak relation. You can see that it's still pretty spread out, but now it's tilted, where knowing exercise, how much a person exercises, tells you a little bit about what their mood is. It's going to elevate their mood a little bit, not a lot. Weak relation. And as those points get tighter, then you get stronger and stronger relations. So this would be a moderate relation. You can see the cloud of points are getting tighter. This would be a strong relation. Cloud of points are getting even tighter. And this would be the, you'll never find it in real psychology, perfect relation, where one predicts the other one perfectly. So in this case, there'd be a very strong relation between exercise and mood, where if you told somebody, oh, somebody came into my office today and they exercise 5 hours a week, they would be able to tell you, oh, they kind of have, a mood within this range of moods, right? They'll probably have a highly positive mood, but it's going to be within a range. That can happen. This almost never happens, where you can tell somebody, oh, somebody exercises 5 hours a day, and they'll tell you, oh, that person exactly has that level of positive mood, and no other level but that. It rarely ever happens. If you ever see this in data that you've collected, you probably entered it wrong. This is only seen in the correlation between height in inches and height in centimeters, speed in kilometers and speed in miles. It's usually an indication that somewhere along the line you've entered your data incorrectly. All right, but it's the maximum amount of relation. That's a perfect relation. Can't get more related than that. All right, so describing relationships. So your relationships can be positive, your relationships can be negative, and we've seen this before, so just real quickly. Positive relation means that as one variable goes up, the other variable goes up, and as one variable goes down, the other variable goes down. So as exercise increases, so too does mood. As exercise decreases, so too does mood. That's a positive relation. The two variables go in the same direction. Negative relation is the opposite. In this case, the two variables go in opposite directions. As exercise increases, depression decreases. As depression increases, exercise decreases, right? If you're going to stay on this cloud of points, as one goes up, the other one has to go down to stay in those clouds of points.